Greetings and welcome, friends. Today we are graphing linear equations. So we're graphing lines in a form of a line called standard form. Now, our previous skill set for graphing has been to make a table of values, right? And then to plot those points, right, Jimmy? Right? And then using those points to try to draw the line that passed through all of them. We're eventually going to try to train you guys that you'll be able to visualize the graph based off of the equation. But today is going to be better than simply using a table of values. And to be honest, I like to have more efficient ways of graphing. So here we go. It says standard form of a linear equation is this: ax plus by equals c. So this is what's called standard form right here, where a, b, and c are real numbers, and a and b are both are not both 0. And if a equals 0, then this whole thing would be 0, right? Because 0 times x is 0. If b was 0, that would be 0. And right, then you just have whatever this term was equal to c. And then then there's a whole bunch of stuff related to a constant. We'll graph those. Here we go. Let's take a look. Horizontal and vertical lines. So horizontal lines are the sideways ones. You could think of the way you might remember is horizon, right? That's when you'd have like a lovely scenery here. Bam. Horizon is like horizontal. Look at that. Was like, guys, that's not a picture that I just put there. I drew that. That is not a photograph. I realize you think you're looking out the window at the sunset right now. You're like, I know we had daylight savings, but no way the sun is setting right now. I just drew that. That's how real that looks. I'm good. So like I was looking out the window the whole time. All right. I don't know. So check this. Horizontal lines will have a graph of the form y equals a number. All right. And vertical lines will have the graph of the form x equals a number. Now, what's weird about that is the fact that the y-axis is the vertical axis in its equation for a horizontal line has got the y in it. And it's the x-axis that's horizontal, but the equation of a vertical line has the x in it. That's weird. And the way I sometimes remember things is by specifically thinking, oh yeah, it's the opposite of what I might first have suspected. And so that's the way I remember this. It's, oh yeah, horizontal lines, it's the y, because I would have thought it would have been x equals a number, but that ain't how it go. That ain't how it go. So, let's take a look at example 1 here. And I've got a graph grid pre-graphed for you. So you guys have this in your packet. Man, I feel like, why is my scale all off today? I don't understand. All right, so it says horizontal and vertical lines. Graph y equals 4. So I'm going to help you out here. Y equals 4 is going to be horizontal. But think about it this way. If I wanted to plot every point whose y coordinate was 4, that would have been like 0, 4. That would have been like 1, 4. It would have been like 5, 4. And like pi, 4. And like negative square root of 2, 4. And yeah, so all of the points that have 4 as a y coordinate end up being a horizontal line. Tell you what, I'm going to use my line tool. You guys are drawing this, right? Yeah, you should, like, the way you should learn things is by practicing them. It's going to be much better. Mo better off. So here's the equation of the line y equals 4. So when it's y equals a number, that is the equation of a line, and it happens to be a horizontal line. It's a linear function. Now, if I want to graph x equals -2, that would be like -2, 0, negative 2 comma 1, negative 2 comma negative 5, negative 2 comma 5, right? And it's going to end up being all of the points right here that would form a vertical line. Okay, verticale line. And this is a line, but it is not a function. Okay, so when you have x equals some number, right, in this case x equals negative 2, that's the equation of the line that passes through negative 2 on the x-axis, all right, but it's not going to be a function because there's multiple outputs for the input of negative 2, right? This would not pass the vertical line test because this vertical line would hit infinitely many points all over the place. So horizontal and vertical lines, those are the somewhat easy ones to graph. It's when they're not horizontal or vertical that it's going to get a little bit more interesting, and I'm going to help you out in graphing in those situations. All right, so here we go. If I wanted to graph a line of the form ax plus by equals c, all right, ax plus by equals c, one of the ways I could graph is by finding the points we'd call the x-intercept and the y-intercept, which are very aptly named points for an equation or a graph. They are the points where the graph crosses the x-axis. It intercepts it, right? Like an interception in football is when the other team's defensive player and the ball are in the same point at the same time, and he intercepts it, he catches it, right? So this is when the graph and the x-axis coexist, right? So here's your x-intercept, all right? And your y-intercept would occur somewhere like where your graph crosses the y-axis. Right. And this is what's interesting. This is the clue. To find your x-intercept, the x-intercept occurs when y equals 0. Once again, that's the opposite of maybe what you would think about. But notice every point on the x-axis did not go up or down. Every point on the x-axis is going to have 0 as its y-coordinate because it had to stay on the x-axis. And similarly with your y-intercept, every point on the y-axis happens to have 0 as its x-coordinate, right? 0, 0, 0, 1, 0, 10, 0, negative 3. That all of these points needed to not move left or right, and so their x-coordinates had to be 0. And we're going to use that fact to find the x and y intercepts for a graph, and that's the way you do it. So find the x-intercept of your equation, you'll plug in 0 for y and solve for x. To find the y-intercept, you'll plug in 0 for x and solve for the remaining variable y. And watch what beautiful graphs we can make with somewhat less effort than making a table of values. Okay, so here's my equation. I want to find the x-intercept. I'll make that blue this time. So x-intercept. I know that the x-intercept, Devin, as your friend is telling you right now, occurs when y equals 0. And y equals 0, that means I can plug in 0 for y. So I'm going to have 3 times x plus 4 times 0 equals 12. And now all I have to do is solve for x. So 4 times 0 is 0. So that's the same as just 3x equals 12. And I will add, or nope, divide both sides by 3. And I get x equals 4. So x equals 4 is your x-intercept. This is the same as the point 4, 0. All right, 4, 0 is where that occurs. So my x-intercept is going to be right here. Ding, 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 ding. What's the question? No, the 4 was... Oh, when I plug... Yes. Yeah, when I plugged in 0, 4 times 0 was 0, and adding 0, I didn't even have to write. Yep. And let's see. Yeah, good question. Good question. Y-intercept. Missing? All right. Let's see. So for the y-intercept, that occurs when x equals 0. So using the same equation, this is in standard form, I'm going to plug in 0 for x. So 3 times 0 plus 4 times y equals 12. 3 times 0 is 0. So that's just the same as 4y equals 12. And then I'll divide both sides by 4. And so I'd get y equals 3. So the y-intercept is at 3. And that's the same as the point 0, 3. And the reason I write this is because sometimes when we find the x and the y, sometimes students will want to say, oh, these two things, here, I'll even put this in red just so you realize this is super wrong. Sometimes people are like, oh, that means that the point is 4, 3, and that is super wrong. In fact, this point won't even land on our graph, never mind helping us to make our line. So these are two separate points, our x and y intercept. They are not the same point. So let's see, graphing the y-intercept at 0, 3, I would go 0, 3 is right here. And then once you have your points, you can now graph your line. Right, so those are 2 points that are relatively easy to find. This is easier than making a table of values with a whole bunch of points. Right, if I plugged in 1, I would have had like some weird decimal value here. I would have had some decimal value there and here. But like the x and y intercepts are super easy to find. And plugging in 0, 0 is like the best number to plug into anything because like 0 just destroyed that entire term by itself. And I didn't have to worry about it no mo. No mo, no mo. All right, so that's a way that you can graph a line without having to make an entire table of values. Let's have you guys try monitoring progress questions 3 and 4. I think I gave those to you. So you want to find the x and the y-intercepts. Hopefully I gave you more space than I gave myself. Yeah. So yeah, a little bit. Good, good. All right, so the way you'd start for your x int, you would set y equal to 0. And you might be able to even imagine some of this. So that's just going to be the equation, right? 2x equals 4. And I get x equals 2. My x-intercept is right here. And let's have you guys find the y-intercept for that one. I'll walk around and help you out. Y-intercept. Yeah, but All right, let's see. Adriana, you want to walk me through how to find the y-intercept for this first problem again? Yeah, so plug in 0 for x, so I'm going to get negative y, or the opposite of y equals 4. And that means y equals negative 4. Right, so if I plot that, y equals negative 4 occurs right here on the y-axis. Oh dear, I just did my symmetry tool. I meant to use my ruler. And then using those 2 points, I can now draw a diagonal line, just like this. Right? Oh, I could have had it continue further than that. There we go. Whatever. And then I put arrows on my line because this line does go infinitely far. And I just want to point out any of the points on this line. So here's the point 1 comma negative 2. Or here's the point 3 comma positive 2. Any of these points, if I was to plug these in for x and y in this equation, they would all make the equation true. That all of the points on the line represent solutions to the equation. It's a visual way of representing them. All right, let's see. Jimmy, could you help me find the x-intercept? What would I do to find the x-intercept on this one? What would I plug 0 in for? I would plug 0 in for the y. Right? So I'd have 3 times 0 is 0. Adding 0 doesn't do anything. So what's my x-intercept going to be? I'd have x plus 0 equals negative 9, which is just the same as saying x equals what? Negative 9, which I just realized my graph does not fit. Bah! Man, Waddy, you got to go back and fix that now, friend. That's all right. We'll fix it. We'll fix it. And then the y-intercept. Let's see, Pooja, what would I plug in and where? 0 for who? Yeah, 0 in for x, so this time I'd have 0 plus 3y equals negative 9, or just 3y equals negative 9. How do I solve that? For y. Yep, divide both sides by 3, and we'll get, yeah, y equals negative 3. So that means my y-intercept occurs at negative 3. And watch this move. Ready, guys? I'm going to change this to 10 and negative 10 on my x-axis. Sneaky. I just done dude it. I dude it, friends. And so x equals negative 9 would be halfway between the negative 10 and the negative 8 right there. Do you have a question or a comment? All right, well, I'm drawing a line. What's up? What's your question? I might have a chance here. Ah, good question. That's because lunch is determined based on your third block class. And if third block class was between 1:20 and 2 p.m. today, we'd all be eating lunch really late. So that's why. Mystery solved. But yeah, so someone did think about it before they did it. Oh dear, I just zoomed. Oh dear, my zoomies are all gone. Okay, let's look at the next example here. Keep cruising. Ooh, example 3. It's a problem about graphing. Here we go. That was my song about example 3. It's a true story as well, which is why it's so emotional for me. Let's see. This time I think I gave you a graph that will actually work. Hopefully our coordinate plane is sufficient. All right, so here we got, it says you need to rent tables to seat 180 people. The tables come in two sizes. Small tables seat 6 people, and large tables seat 10 people. The equation, so here's our equation, 6x plus 10y equals 180, models this situation. So x would be the number of small tables, y would be the number of big tables, and if I take x and multiply by 6, that would be the total number of people that are seated at small tables. And if I take y, the number of big tables, and multiply by 10, that would be the total number of people that are sitting at big tables. And if I add those two together, that needs to equal 180. All right, that's where that equation came from. We'll practice writing those sorts of equations later on. It says, so it models this situation where x is the number of small tables and y is the number of large tables. It says graph the equation and interpret the intercepts. Okay, so I already forgot it. What was the equation? 6x plus 10y. Question, comment? Oh, I'm not ready for the answer yet. But could you help me find the x-intercept? What would I plug in where? Yeah, y equals 0 to find the x-intercept. So, right, so 10 times 0 is 0. I can just get rid of that. And let's see, so we'd have 6x equals 180. All right, she said to divide. And I'm going to get x equals 30. And my x-axis represents the number of small tables, right? And my y-axis represents the number of Alg tables, largo. And our x-intercept occurred at 30. Oh, I was going to do blue for that. There we go. A very nice blue. All right. Someone else, Ethan, could you help me find the y-intercept? Man, you guys are pros. And if I do that, 6 times 0 is 0. That's just going to simplify down to being 10y equals 180. And now what do I do? I like it. I like it a lot. And so I'll have y equals 18. So our y-intercept, by the way, this is the point 0, 18. This is the point 30, 0. You don't have to write that, but that might help you remember kind of where those points are. Let's see, it looks like I have grid lines. Maybe they printed well on yours. If this is 5, it looks like each of those grid lines counts as 1. So here's 15, 16, 17, 18 is right here. And let's draw my line. Drawing my line. Man, it's nice when my graph works out like this. And my line, in terms of domain, I don't have it keep going to the left. Because I can't have a negative number of small tables, right? I can't seat people at antimatter tables. That doesn't work, right? And I don't have my line continue over here because I can't have a negative number of large tables. That doesn't make sense. This does not exist, all right? So here's my line. Now they said interpret the intercepts. What does 30, 0 mean in terms of this problem? What were the x's and the y's? X is the number of small tables, right? And y is the number of large tables. So 30, 0, what would that mean for this problem? That, yeah, we can seat 180 people at 30 small tables and 0 large tables. I didn't hear your question, I'm sorry. All right. And what does this point represent in terms of the problem? That would be if I only rented large tables. I'm assuming I'm renting. I don't remember this problem anymore. That would be if I rented 18 large tables, 0 small tables, and I still could seat 180 people. All right, then they asked, find 4 possible solutions in the context of the problem. Now, question, here's a point on the line, but I don't think I can have half of a small table and then like 17 3/4 or whatever large tables. I'm assuming this problem actually probably should have been discrete and not continuous, but that's okay. So let's see if we can find some points on the line. It looks like right here is one, I'm thinking. Looks like if I go down 3/5, it's hitting each time. Down 3/5, down 3/5, down 3/5. Yeah, down 3/5. So here's a solution. This would be 5, 15. Let's see. What would that mean in terms of this problem? Yeah, 5 small tables, 15 large tables can seat 180 people, right? Here's 10, 12. So that would mean 10 small tables and 12 large tables would seat everybody. Right over here is, looks like 25, 3. I could have 25 small tables and 3 large tables. That any of the points on this line would represent possible solutions of that equation. And so maybe for some reason you'd only want large tables, right? Maybe for some reason you'd only want small, or maybe some combination of the two would make sense. Like here, 15, 9 apparently works, as well as 20, 6, right? They only asked for 4, but that's what this represents. Possible combinations of small and large table solutions. All right, thanks for watching, Internet friends. We're going to do some class question. Bye-bye.